I was asked by the organizers to speak about factor VIII assay discrepancies and clinical impact. So we are using these assays for assigning the patient a diagnosis. We are using these assays for monitoring treatment, for either prophylaxis, bleeds, or surgery. And these assays are also used for assigning the potency of the factor VIII concentrates in the vials by the chromogenic assay here in Europe, or by the one-stage assay in the US by the FDA, which now may have changed for one of these products where the FDA also allowed the assignment of the potency with a chromogenic assay. The one-stage assay is used in most treatment centers in Europe, but also over the world. Most of us, we are giving a sample to a central laboratory, and we are getting back a value. We do not really know always what this value means exactly, but we are basing our treatment on this value. And I will go through a few points, like the principles of the one stage and the chromogenic factor VIII assay, show examples where assay discrepancies are inherited. Then I will go for discrepant assays for assigning potency in clotting factors, the classical products, but also with respect to the new products that are coming, and the challenge of assays with some new biomolecules. This is a principle of a one-stage assay. We have a plasma sample, and this plasma sample is diluted, not too much. In this example, it's 1 to 10, but it could be also less. Then we have an APTT activator. We are incubating the sample. The clotting process is started by a starting reagent, and then for an APTT-based clot formation is assessed. We have the clotting time, and we have here the factor VIII concentration, and it's a sigmoidal curve. It's a curve where at higher factor VIII concentrates, the clotting time is not really differential, so then we have to dilute the sample to get in this area where we can really distinguish activities with respect to the clotting time. So we have a factor VIII deficient plasma to which we are giving the patient sample, and in this factor VIII deficient plasma we have all components that we also have in a circulation in a physiological condition, and these components are present in a physiological concentration. That is very important for understanding these assay discrepancies. In the chromogenic assay, we have a much stronger dilution. It is about 1 to 40, and we have only very selected components in this assay. So these components are thrombin, which activates factor VIII. We have activated factor IX and factor X, and the result is an activated factor X, so factor Xa generation. And in the second step, a substrate is given to this reaction, and light extension can be measured. So overall, we have a factor VIII concentration that correlates very linear to the maximal extension of a fluorescent signal. So it's a very purified system with only few reagents. These reagents are highly purified, and they are given in excess to this reaction. So this is a small summary of the assay principles. The one-stage assay has a small dilution. The chromogenic assay is highly diluted, Here we have all coagulation factors present except factor VIII at physiological concentrations. Here we have a highly purified components, either of bovine origin in most chromogenic assays or human origin. This assay is APTT based, and we are measuring a shortening of the APTT assay, and here we have a factor 10A generation. For the one-stage assay, we have a huge variation of kits, reagents, conditions, and analyzers. For the chromogenic assay, we have much less different components. So now I would like to come to the inherited assay discrepancies, which can be used as a model for understanding why these assays are different to some extent. And it's very interesting that in non-severe hemophilia, there's a very significant proportion of patients who show discrepancies in these assays. So if you take a cutoff level of 0.5 as a ratio of a one-stage assay and a chromogenic assay, then about 1/3 of the patients are discrepant. In a survey in our center, we had looked at 284 patients with non-severe hemophilia A and found a discrepancy in 109 patients. This is an overview over the literature where a number of mutations have been published that are discrepant between the one-stage and the chromogenic assay. In this example, most samples were measured with a higher value in the one-stage assay than in the chromogenic assay. This publication, in this patient here, the hemophilia is even not recognized by the one-stage assay, but showed much lower values by the chromogenic assay. And I think this family is from Sheffield. And the publication is from you, Dr. Keeling. Yeah. So there are huge differences in these assays. These are the 109 patients from our center, where we identified 28 different mutations, some with a higher activity in the one-stage assay than the chromogenic assay, and others mutation with a lower factor VIII activity in the one-stage assay than in the chromogenic assay. And this is a list of those with a higher value in the one-stage assay, and I just would like to point to two patients. One is here with this mutation where we have a severe hemophilia in the chromogenic assay and a moderate severe hemophilia in the one-stage assay, and the patient here with this mutation where we have a moderate severe hemophilia in the chromogenic assay and a mild hemophilia in the one-stage assay. And all these mutations have in common that they are located. So this is a cartoon of the factor VIII structure with the various domains in yellow, blue, light blue, and dark blue, the A1, A2, and A3 domain. In purple, the C1 and C2 domains. And these mutations have in common that they are all at the interfaces between these domains. And the hypothesis is that the dilution of the highly dilution of the factor VIII in the chromogenic assay and the incubation time facilitates the dissociation of the factor VIII domains so that the chromogenic assay is showing a lower activity than the one-stage assay. This is just the other way around, where the chromogenic assay shows much higher values than the one-stage assay. And I would like to point only to these patients at the bottom, where the chromogenic assay does not diagnose the hemophilia at all. So they all show normal values between 50 and 100%, between 90 and 120%, while the one-stage assay shows much, much lower values between 15 and 30%. And all these mutations have in common that they are either within the thrombin cleavage site or closely related to a thrombin cleavage site in the factor VIII molecule. There is not a clear pattern of those mutations that can be recognized, but an explanation can be found for the mutations that are at thrombin cleavage sites, because these mutations at the thrombin cleavage sites where factor VIII is activated, they cause a lower affinity of thrombin towards the factor VIII molecule. And in the one-stage assay, we have physiological concentrations of thrombin. So this lower affinity is resulting in a lower factor VIII activity. In the chromogenic assay, we have high purified amounts of thrombin that is overcoming easily this lower affinity. So there we have no reduced factor VIII activity. Clinically, these patients have a mild hemophilia A phenotype. So there are issues of these discrepant assays. There's a question where to set the cutoff level to define discrepancy, which assay to use to define the degree of severity in hemophilia patients, to understand the mechanisms that lead to these discrepancies. And we have performed a small study that was supported by the EAHAD Society with about 6 labs, very experienced labs with respect to assay, all expert labs from Bonn, the Paul-Ehrlich Institute, in Sheffield, Steve Kitchen, Malmö, Andreas Hillab, then Stephen Rosen, who's developing those assays himself, and Claude Nigurier from France. And what we did, we took samples from 34 patients. We aliquoted these samples and then sent them out to these 6 laboratories. And very different assays were applied, a huge number of assays. And the conclusion was that the inherited ratios were confirmed by the majority of the assays, but there was also a very strong local laboratory influence, even sometimes for the same assay. And here I have a few slides. Andreas Hillab made this evaluation. Each symbol is representing a different laboratory, and these are the results summarized for all one-stage assays. And this is the result of the local laboratory compared to the mean of all one-stage assays. And it can be clearly seen that some are very close to the mean, but some assays are either significant higher or, as our Bonn assay, lower than the mean. And this is also shown here, where we have here the mean value. So there is a huge variation that is laboratory depending within the one-stage assays. And we have done the same for the chromogenic assays. Again, the local value against the mean. Overall, the scattering of the results is much less. These are 2 patients with these mutations at thrombin cleavage sites. So also here, the chromogenic assays are quite variable, although they are all in a much, much higher area than the one-stage assays. And here, again, the overall variation is seen. So there is, again, some local lab-depending assay variation that could be seen by the chromogenic assays. So from these results, there was a consensus recommended that all patients with a non-severe hemophilia should be investigated for the first diagnosis with a one-stage anti-chromogenic assay. Okay, now I would like to come to the discrepant factor VIII assays with respect to defining potencies and treatment monitoring with the new clotting factor concentrates. Every 3 months now a new clotting factor concentrate is licensed and they are behaving very, very different to the assays. So this is with the classical concentrates, and we have published this a few years ago. Here we have, these are 4 recombinant clotting factor concentrates. The blue ones are the same, that are distributed by 2 different names, but they have the same production site. And here are the values with clotting, one-stage clotting assay, and here with a chromogenic assay. Here we have a factor VIII assay. 100% would be the labeled potency, and you may know that the companies allow for a 20% deviation up and down. These 2 concentrates here, they are calibrated with a one-stage assay, and with a one-stage assay they are perfectly in the labeled range, while these 2 concentrates here, they are the potency is determined with a chromogenic assay, and they are only with a chromogenic assay within the labeled range. If you compare the blue and the yellow concentrates, the blue contain much higher, much more factor VIII inside, although they were labeled with the same potency. And this is quite a significant difference. This is antigen content, and also it could be seen that these 2 concentrates here, they have a much higher antigen content than these 2 concentrates here. You have to go for the blue column, which represents a monoclonal antibody for factor VIII antigen measurement. This is a B-domain deleted clotting factor concentrate, which does not respond to a polyclonal antibody. So we are using factor VIII concentrates which different potencies with different amounts of factor VIII despite a very similar labeling. We looked at a lot of, at 109 batches from about 10 factor concentrates. These results are unpublished. And again, this is with a chromogenic assay. We see that most are perfectly in the recommended range. These 2 that are the same that I showed before are significantly higher. And this is a potency when it's measured with a one-stage assay. It's an in-house method. And here 3 recombinant products are at the lower end of the recommended range. So the potency determination has an influence on the content of factor VIII. This is a study that shows that also the cell line which is producing the factor VIII may have a different on assay discrepancies. So this is a human HAK cell line. These are COS cells, and these are CHO cells. And why in HAK cells and CHO cells, the one stage and the chromogenic assay corresponds quite well. In COS cells, the one stage assay was much higher than the chromogenic assay. So this maybe is a result of specific intracellular enzymes involved in the trafficking of the factor VIII molecule, or more likely cell-specific glycosylation pattern that influence factor VIII activity measurement. So with respect to the new products, we have again several challenges between the one stage and the chromogenic assays, and also with respect to the potency determination. All these new products in Europe are the potency is determined with a chromogenic assay. And if you go through these new products that are now available, the fusion proteins, the modified sequence protein, factor VIII concentrates, the pegylated factor VIII concentrates, some of these products can be measured with either assay. So with the one stage and the chromogenic assay. Other products require specific assay compositions as ellagic acid as an APTT reagent for the one-stage assay. And other products can only be analyzed by the chromogenic assay and require a conversion factor when they are measured by a one-stage assay. And the difference of these assays and the behavior of the clotting factor concentrates, these are detailed in a review paper from Flora Pivande, published 2015 in the Journal of Thrombosis and Hemostasis. So if we look at these new products, we have several options. We can use the chromogenic assay, which in principle is more robust towards these new concentrates. We can use the one-stage assay with a special composition that is allowed to determine the activity in those concentrates. We can use concentrate-specific reference standards, which is quite complicated, or can use conversion factors. But all this is quite cumbersome. There are some councils that have tried to make recommendation. One recommendation is that the chromogenic assay may become a more and more significant role in the future, especially with these new products, because this is the assay that is most robust to these new products. And also the FDA is now moving slowly towards acceptance of the chromogenic assay as a potency assignment. At last, I would like to show the complexity with respect to a factor VIII mimetic molecule. This is a emicizumab. If you go for measuring the factor VIII mimetic activity, you can only do this by using the chromogenic assay from Hyphen, because only human-derived reagents are interacting with this bispecific antibody. If you want to assess substituted factor VIII-C, for example, in case of surgery or bleeding, in a non-inhibitor patient in the presence of this bispecific antibody, then you have to use a classic chromogenic assay with the bovine reagents that do not interact with the antibody. All APTT-based assays do not work because they are too sensitive in the presence of the bispecific antibody. And if you want to do an inhibitor measurement in such patients, you can no longer use the classical Bethesda assay that is based on a one-stage assay, but you have to go for an ELISA, or you have to do the Bethesda assay with a classical chromogenic assay. So this is just an example that treatment in the future can become quite complex. And here's a summary that for the one-stage assay, we have physiological concentration of the components. Here we have high diluted factor VIII concentration, very purified components. This is the one preferred in the past by the FDA for potency assignment, the chromogenic assay by the EMA for potency assignment. The one stage is very sensitive to factor VIII activation. The chromogenic is not. This one is inexpensive. This is more expensive. We have large varieties of assay kits, reagents, and conditions. With the one-stage assay, much more than with the chromogenic assay. We have a higher interlaboratory variability with the one-stage assay than with the chromogenic assay. We have an underestimation of the potency for recombinant products with the one-stage assay. This assay is not very suitable or only suitable in specific compositions for the new products that are that are entering now more and more the market. Thank you very much for your attendance.